Hi guys, here are the solutions to our Unit 2 quiz. And right off the bat, I apologize. I kind of said that these were multiple choice, and I forgot that they were mixed up. The items always they get mixed up. So 1, 2, 3, 8, and 9 weren't multiple choice, but there were indeed 5 multiple choice ones, and I think it was obvious to see which was which. Number one, the number one that I got, what is the domain and interval notation of this? Well, this is a line, and lines, they always have a default domain of all real numbers. So for here, you would go into the fx thing and type in negative infinity all the way to infinity and make sure it looks the way you want it to look. Press done, and it converts it to some sort of code. But then when you submit it, it'll look like what you want it to look like. Unfortunately, you can't. That's a defect of this program. But you'll just have to trust that you did it right, I guess. The second one I got, this is f of g, not f times g. So this is f of g of x. So that is f of g of x, which is 4x minus 1. And f takes 3 times the input plus 13. So 3 times 4x minus 1 plus 13. And that becomes 12x minus 3 plus 13, which becomes 12x plus 10. Some people multiplied. I'm sure you're frustrated by that, but that's a mistake that can be quickly fixed and therefore kind of resurrected in the test, since the tests are worth much more. So this open circle means composition. If it were a tiny closed circle, it would be multiply. But when I've been using multiply, I always just do fg next to each other. That would be f times g. Okay, what is the domain of this? F times g of this. So remember, f times g of x is the same thing as f of x times g of x. So the x is going into f and g. That means that your domain has to be acceptable to both f and g. So let's see if I did this one over here. No, I did not. So for g, 6x plus 4 cannot be negative. So it has to be greater than or equal to 0, which means 6x has to be greater than or equal to negative 4, which means x has to be greater than or equal to negative 4/6, which is negative 2/3. That's the domain for g. For f, 5x minus 4 has to be greater than or equal to 0. Which means 5x is greater than or equal to positive 4, which means x has to be greater than or equal to 4/5. Now, both of these things have to be true because x is going into f and x is going into g. Both had to be true. Well, if x is greater than or equal to 4/5, it is by consequence already greater than or equal to negative 2/3. So the domain is just this one. X is greater than or equal to 4/5. You can't say this one. You can't just say it has to be greater than negative 2/3. That would be okay for this, but 0 is greater than negative 2/3, and 0 won't work for g. So you have to find a domain that is acceptable to both. In other words, it's the intersection of both domains, and it's this one. So you would do bracket 4/5 all the way to infinity. Infinity always ends in a parenthesis. That's how it should look, including 4/5 going to infinity. Press done, and it will submit a code. But once you submit the whole test, it'll transfer that code to math symbols. Okay, and this is not f times g, this is f of g. So 6 is going into g, and then g will produce something, which in turn will go into f. Now this one I know I've got right here. So 6 goes into g. That means 8 times 6 minus 10. So that's 48 minus 10, which is 38. Now 38 is the range of G, but that is becoming the domain of F. So 38 goes into F. F takes 12 times 38 squared minus 9 times 38, which is this. Grab your calculator. You get 16,986, which is the first option for me. My number 5, find the domain of this composition. So this one I have worked out as well, right here. So first of all, when we talk about domain of a composition, I always like to think that all real numbers. It's just, let's let X have equal everything. And now X is going into G. Now G is 4 divided by 3X. So right off the bat, X cannot equal 0. One second. Okay, I was actually looking at the wrong problem, so excuse me. This one you're finding the domain of this, which is here, right? So f of g of x. Well, this one order matters because composition is not commutative, so the order matters. And x, let's just imagine x could be anything. Well, x goes into g. G is x plus 2. That means x can still be anything because you could take any number and add it to 2. That's fine. But then now this is going into f, and here's where there's a problem because f takes 4 divided by the input plus 7. So now there's a couple of different, right here, this guy right here, that value cannot be negative 7. This value cannot be negative 7 because if this were negative 7, you'd have negative 7 plus 7 and you'd be divided by 0. That would be a big problem. So you had to find what x value would make this equal negative 7. And of course, it's negative 9. So at this point, you actually know that x cannot equal negative 9. But even after you simplify, when you look at the final answer, there's a reminder, x clearly cannot be negative 9. So this is the domain. It's all real numbers except for negative 9. And that's what I would put here. And I'll just skip that part because we've done that a few times. And then now this one. Okay, another multiple choice, f of g. And it doesn't even look like f times g is a possible answer here. So none of these are even f times g. So f is receiving g of x, which is, this is the one that I made a mistake on earlier. So f is receiving g of x, and g of x is 4 divided by 3x, and that's what f is receiving. Well, f takes 4 divided by the input minus 6. So 4 divided by the input minus 6, and this is the composition. We just had to simplify, of course. So you got two fractions here, get a common denominator. I'll change this 6 to 18x over 3x. Now I can subtract them. I get this fraction. Now I have 4 divided by a fraction, so I flip and multiply. 4 becomes 4 over 1. And I change division to multiplication, and this fraction gets reciprocated. Now I take 4 times 3x, which is 12x. The denominator is 1 times this, so this is our final answer, which is, I think it was this one. I can't, But it's worth mentioning going over the domain here because the domain is more challenging to figure out. Again, let x equal all real numbers, and then right away when x goes into g, all real numbers are not accepted by g. G takes 4 divided by 3x, so x cannot be 0. So now this is the domain so far, but there's more to go. F is receiving this. So f takes 4 divided by the input minus 6. And again, as long as this, if this is 6, we're in big trouble because 6 minus 6 is 0. So I cannot allow this to be 6. I have to figure out what x value would make this 6. And then I have to exclude that. Well, I can't do that in my head, so I use algebra. 4 divided by 3x, let that equal 6. Multiply both sides by 3x, divide by 18, I get 2/9. So now 2/9 will make this 6, which will make the whole denominator 0. So 2/9 is a no-no, cannot be in the domain. And already 0 was out of the domain. So now my domain has been limited a little bit more. All real numbers, except for 0 and except for 2/9. Okay, transformations. So radical x is this solid, bad photocopy, but this line right here, this graph. And 3 transformations. First of all, to the left one, this negative sign flips it upside down, and this +2 raises it up 2. So, for instance, this ordered pair would go to the left 1, it would flip upside down, and then it would go up 2. So we need to find that. And this looks like it. This looks like here's the ordered pair 2, or 4, 2. To the left 1 becomes 3, 2. If I flip it upside down, it becomes 3, -2, and then up 2 gets me right back here. So it's this one. Notice the beginning point is right here. So that's indicating that the starting point moved to the left 1. And then if you flip it, you're still right there. And then raising it up 2 brings it right there. Here's another multiple choice with transformations. So f of x is this, looks like a parabola, but only part of a parabola. And 2 transformations, negative f of x. So this f of x gets flipped upside down, and then +2. After it's flipped upside down, it raises up 2. Well, this one got flipped upside down and went to the right 2. This one got flipped, this one just moved to the left 2. This one got flipped upside down and moved down 2. This one got flipped upside down and moved up 2. What is the domain of this? Well, okay, so this is one function, and to find the domain, there's really 2 things you have to watch out for: division by 0 and square rooting a negative. Can't do either one of those things. And I'm not square rooting anything, but I am dividing. So x cannot be 3, x cannot be -2, and besides that, x could be anything. So x is anything except 3 and -2. So negative infinity to -2, union that with -2 to 3. Don't forget all those numbers in between -2 and 3, and then 3 to positive infinity. Of course, you should use the f of x, the fx button, the math quill, to get the nice symbols going there. What is the domain of, okay, composition f of g of x? So this g is going into f. And this one I think I have somewhere. Okay, right here. The answer is 7 to infinity, because first of all, assume all real numbers. Now, x is going into g. G does not accept all real numbers. G can't accept -10. It would be imaginary. So G can only accept numbers 7 and greater. So that's the domain right now. And then radical x minus 7 goes into f. F squares what it receives and then adds 7. So you square this radical and then you add 7. Squaring the radical cancels out, so it's x minus 7 plus 7. Those cancel out, leaving you with x, and this gives us evidence that f and g are inverses of each other, which you now know, but that's not part of this quiz. So the final composition is x, which normally is just a line, y equals x. That would normally have a domain of all real, but this is the consequence of this composition. So the domain has to be applicable to these steps. That means the domain is 7 to infinity. Another transformation, radical x minus 2. So just a radical x, but then shifted down 2. This one is shifted up 2. This one is shifted down 2. What's the domain of this? You're not taking the square root, but you are dividing. You are dividing by x squared minus 9. Well, you can't divide by 0. So what x values would make you equal 0? 3 and negative 3. X cannot be positive 3 or negative 3. So it's negative infinity all the way to negative 3, and then pick it up again at negative 3 all the way to 3. Don't forget those middle numbers. A lot of people forget the middle part. All the numbers between negative 3 and 3 are okay. And then 3 to infinity. But I would prefer if you did the fx. I'm just trying to save time. And then that's it. Submit.